Good morning, friends. Today we study the chapter 5th 9th class Euclid's Introduction to Euclid's Geometry. In this chapter, now we study the Theorem 5.1. Theorem 5.1 is telling two distinct lines cannot have more than one point in common. Cannot have more than one point in common. Friends, for proving this, we assume that two lines L and M. Two lines L and M. We know that they have only one point in common. One point in common. We need proof that they have only one point each common. One point is common, friends. For proving this, we assume that two lines intersecting in two distinct points. We suppose that two lines intersecting with two distinct points P and Q. Two lines this L and M we assume intersecting the two distinct points P and Q. P and Q are two distinct points. Now two lines passing two distinct points P and Q. Two lines is passing through two distinct points P and Q. That is class the assumption that only one line can pass through the two distinct points. So friends, we telling that two lines can pass through two distinct points is wrong, because it class the Euclid assumption that only one line can pass through two distinct points. So we telling forcefully that two distinct line cannot have more than one common point. Friends, now we solve the exercise 5.1. Exercise we solving. Exercise 5.1. Friends, we also solve this exercise. We define question by question. First question is given: which of the following statements are true and which are false? Give the reason for your answer. Only one line pass through a single point. Only one line pass through a single point. Friends, this statement is false because we can draw infinite line from a single point. From a single point. Friends, you see, this is a single point. We can draw infinite line this direction, this direction, this direction. So we can draw infinite line from a single point. Second statement is given. There are infinite number of lines which are passing through two distinct points. This statement is also false because Euclid tells that only through two distinct points only one line is also passed. According to axiom 5.1, two distinct points, there is a unique line that passes through them. Question number 3. A terminated line can be produced infinitely on both sides. Friends, we solve this problem in the example also. This statement is true. Friends, fourth question. If two circles are equal, then their radius are equal. Friends, in this statement telling if two circles are equal means their area are equal. Circles have area means their circles have area means their area are equal. If their area are equal, then we telling that they have same radius. So we write that if two circles are equal, then their area are equal, and from the relation are the formula of area circle area we find out by pi r square. So then the relation from the relation area equal to pi r square, we telling the if two circles are equal, then their radius is same. Now we take fifth question. Figure 5.9. Figure 5.9. This is figure 5.9. Figure 5.9. Figure 5.9. If AB equal to PQ and PQ equal to XY, then AB equal to SY. That is true. According to assumption, if two things are equal, separately, then equal two things are equal, then equal to the third things, two things are equal to a third things, to a third things, then they are equal to each other. Means A, B or PQ are equal, and these both things are equal to another things XY. Telling, so be telling that AB equal to SY through the examples. Now question second. Give a definition for each of the following terms. Are there other terms that need to define first? What are they and how might we define them? Give the definition of each flowing term. हमें flowing term की definition देनी है. He required the definition of the flowing term. First term is parallel line and telling that are there other terms which need to be defined first. Other term are there other terms that need to define first? What are they and how might you can define? How might you can define? Means in parallel line, defining the parallel line need another term. What is term? Parallel line. Parallel line by definition, two straight line which have no common point, which have no point in common, are said to be parallel to each other. Are said to be parallel to each other. Two straight lines which have no common point are said to be parallel to each other. For defining the parallel line, two terms is generated: straight lines and points. Straight line and point. Point and straight line as defined in Euclid texts are point. A point is that which have no parts. A point which has no parts. A straight line is breathless length. A line is breathless length. A line is breathless length, and a straight line is a line which lie evenly with the point on itself. A straight line is a line which lies evenly with the point on itself. Now we take problem number second. Problem number second is perpendicular line. Perpendicular line, for defining the perpendicular line, if one among two parallel line is turned by 90, one among two parallel line turn by 90, then the two lines become perpendicular to each other. Friends, in the definition, term is come parallel line. Parallel lines. We also define what is the parallel lines. Parallel lines, two lines which have no point in common. No point in common. Now we take third problem. Third problem is line segment. Line segment, but if we terminate a line, we produce many line segment. So a line segment with two end point is a line segment. A line segment क्या है? A line segment two end point, a line with two end point. A line with two end point is called line segment. Suppose ये एक लाइन, दिस इज ए वन लाइन A, B. We terminate this line. Here we telling a line with two end point. This line have two end point. This line have two end point. Means this line is finished this and this point. So this is a line segment. For defining the line segment, produce two terms. First line, second point. Line and point. We also define what is line and what is point in first problem. Line is breathless length. A line is breathless length, and a point is which has no parts. Now problem number fourth. Problem number fourth is tell radius of circle. Radius of circle, the line segment which one end point at the center and other have even at any point on the circle. The line segment with one point with with one end point at the center and other end point have win at any have win on the circle, that is called radius. Now for defining the radius, two terms are generated: center and circle. Center may be defined as a point inside the circle, which is at the same distance from all points on the circle. All point on the circle. Now, fifth problem, square. What is square? A equilateral with all sides equal. A equilateral with all sides equal and all angle right angle is a square. A equilateral means equilateral, all side. With all side equal. Equilateral with all side equal. And all angle right angle. All angle is right angle is called square. Because we see in square that A, B, C, D is a square. We see that this and this is a lateral. This is a line. This line is called equilateral if these lines are equal. These lines are equal. And each angle where you meet produce right angle, then this geometry is called the square. Friends, now take third question in next video.